Today's lesson is about solve a sin x plus or minus b cosine x equals c pattern trig equations. There are a lot of methods to solve this kind of trig equation. But for all methods, you have to use sum and difference identities. You can choose any of these four trig identities to solve this kind of trig equation. But for me, I want to choose these two. The reason why is the sign, positive, positive, negative, negative, so that the students won't be messed up. For cosine, you have to remember this is a positive and then it's negative. That's the opposite sign. Here's a negative, this is a positive. It's easy to mess up with this sign. That's the reason in this lesson I choose the first two to solve this kind of equation. First step, you have to make sure a is greater than 0, because I want that theta is first quadrant angle means reference angle. It has an advantage when we deal with this kind of equation without calculator, because everyone is good at reference angle. So first step, after you make sure a is greater than 0, find the square root of a squared plus b squared. Then divide both sides of equation by square root of a squared plus b squared. Then you make a over square root a squared plus b squared equals cosine theta to find this angle theta. If we already make a is greater than 0, that means this theta will be reference angle. Then use the backwards of sum and difference identity. Sin cosine plus cosine sin, then you can change into this format. So remember, as C, C, S. Then after you change the trig equation into this pattern, then you can solve. Let's go to example 1. Solving trig equations in the domain that's from 0 to 2 pi. No calculator. Before you go to any trig equation like this, make sure it's a sin x plus or minus b cosine x pattern and a greater than 0. For number 1, we already know that's a sin plus cosine pattern. And a equals 1, b equals 1. Therefore, square root a squared plus b squared, that's 1 squared plus 1 squared, equals square root of 2. Your first step. Second step is every term for this equation you divide it by square root of 2. Therefore, we got square root of 2 over 2 sin x plus square root of 2 over 2 cosine x and equal to negative square root of 2 over 2. Then our next step, you will make this number, that's a square root of 2 over 2 set up equals cosine theta. We know theta will be reference angle and theta equals pi over 4. Then next step, you will change this function into sin x. This is a plus, so over here is a plus pi over 4. then equals negative square root of 2 over 2. The reason is that for square root of 2 over 2, I can do cosine pi over 4 sin x plus for this square root of 2 over 2, I can do sin pi over 4 cosine x. And we can do sin x cosine pi over 4 plus cosine x and sin pi over 4. SCCS, that's how you get the sin x plus pi over 4. You don't have to show this work. You just remember this rule. Whenever you get theta, then you get the sin x plus theta or minus theta. Depends on this sign. Is it positive, then just x plus this is theta. If this is a minus, then you get the x minus theta. Then we can solve this trig equation now. The reference angle for sin equals the square root of 2 over 2, that's pi over 4. And this is a negative. That's why we go to third and fourth quadrant. Then you got 5 pi over 4 and 7 pi over 4. Then check this angle equals to this or equals to this. So we got two equations, x plus pi over 4 equals 5 pi over 4. Also, we got x plus pi over 4 equals 7 pi over 4. Then cross equal sign, we change the sign. You will get the x equals 4 pi over 4. That's pi. For this equation, I will minus pi over 4. You will get the x equals 6 pi over 4. That's 3 pi over 2. That's your solution. Let's go to number 2. First of all, for this pattern, remember, and we do a sin x, the first position. Therefore, we will move this sin x first, then plus square root of 3 cosine x equal to negative 1. And we got the a equals 1 and a b equals square root of 3. Therefore, a squared plus b squared, we do the square root. You will get 1 squared plus square root of 3 squared. We will get 1 plus 3, that's the square root of 4. That means 2. Therefore, we divide it by 2. And rewrite this one. We got the 1 over 2 sin x plus the square root of 3 over 2 cosine x equals to negative 1 over 2. Then we set up 1/2 equals cosine theta. And theta will be reference angle, that's pi over 3. So we got to change this one into sin x plus, because this is plus, pi over 3. That equals negative 1 over 2. Then we solve this equation now. Go to the reference angle. You will get pi over 6. Since for sine function is a negative 1/2, which means they go to third and fourth quadrant. Angle will be 7 pi over 6 and 11 pi over 6. Then we set up this angle equals to these two. Therefore, x plus pi over 3 equals 7 pi over 6. Then we set up x plus pi over 3 equals 11 pi over 6. Then we solve for this. So cross, you got the negative pi over 3. Remember, cross equal sign change sign. Make sure we got the same denominator. That's why we multiply by 2. So x equals, denominator is 6. 7 pi minus 2 pi will be 5 pi. So for this equation, I cross equal sign change sign. Then I multiply by 2 denominator and a numerator so that I can make the same denominator. 11 pi minus 2 pi, that's 9 pi. So x equals 3 pi over 2. This is your x1, here's x2. This is the final answer. Now let's go to number 3. Make sure A sin x pattern. And A is a positive number. Here's A, that's negative. That's why I change sign for everything. So we got the negative cosine x, positive square root of 3 sin x, and negative square root of 2. Let's rearrange. We got square root of 3 sin x. Remember, always the sin x the first position, minus cosine x equals to negative square root of 2. In this way, and that theta will be the reference angle. Make things much easier. Still, for square root of 3 square plus negative 1 square, do the square root, you get the square root of 4 equals 2. So we divide it by 2. We got the square root of 3 over 2 sin x minus 1 over 2 cosine x equal to negative square root of 2 over 2. Then we set up square root of 3 over 2 equals cosine theta. And we know theta equals pi over 6. Therefore, this one we will change into sin x. This is a minus, so minus pi over 6 equals to negative square root of 2 over 2. And first of all, we get the reference angle. That's pi over 4. Because sin pi over 4 equals square root of 2 over 2. Then this is a negative. That's why we go to the third and fourth quadrant. Angle will be 5 pi over 4 and 7 pi over 4. Then we will make this angle equals to these two. So we set up x minus pi over 6 equals 5 pi over 4. And also x minus pi over 6 equals 7 pi over 4. We need to solve these two equations to figure out this x. We add pi over 6. We add pi over 6. For 5 pi over 4 plus pi over 6, since your denominator is not same, you can do that cross multiply to get the answer, but you need to reduce. Or if you know the LCD, that's 12. Then you can just say multiply by 3 here, multiply by 3, multiply by 2, multiply by 2. you still get the same denominator, that's 12. So 15 plus 2 pi, that's 17 pi. So x will be 17 pi over 12. Or if you want to do this way, say cross multiply, you will get the denominator multiply is 24. Here is 30 pi plus 4 pi. Get the 34 pi. Then you reduce, you will get the 1270 pi. It's really up to you which method is better for you. So we go over here. I still doing denominator multiply is 24. Cross multiply. You got the 42 pi plus 4 pi. That's 46 pi. Reduce, you will get the 23 pi over 12. So this will be the final answer. Let's go to number 4. For number 4, we already know that's a sin x front, a sin x, and this a is greater than 0. So you don't have to do any change. And we got the a equals 1 and b equals negative square root of 3. So we got square root of 1 square plus negative square root of 3 square. That's square root of 4 equals 2. Therefore, I divided by 2. Then rewrite this equation. We got 1 over 2 sin x minus square root of 3 over 2 cosine x equal to square root of 3 over 2. We set up 1/2 equals cosine theta. Theta equals pi over 3. Therefore, I can write down sin x. This is a minus, so we do minus pi over 3 equal to square root of 3 over 2. Then we go to reference angle, that will be pi over 3. Since for sine is a positive, therefore we will go to the first and the second quadrant. That will be pi over 3 and 2 pi over 3. So we make this angle equals to these two. You will get two equations now. That is x minus pi over 3 equal to pi over 3. And also x minus pi over 3 equals 2 pi over 3. Then we solve this separately. We need to add pi over 3. That's x equals 2 pi over 3. For this one, we need to add pi over 3. You got the x equals 3 pi over 3 means pi. So that's your x2. This is x1. This will be the solutions.